Okay, so this is 14B in the this is 14B in the Cambridge book. Watch the video first, and then we'll talk about how to find the angle between two lines. Okay, so 14B starts up with the angle between two lines, and I want to make the point that the idea behind the angle of two lines is that you're going to look at the direction vectors. You're not going to look at the point on the line. The question is, how do we show that actually? So I'm going to use Cartesians to kind of make the point. So I'm going to look at y equals qx plus, I'm going to use an unknown for b because I want to be able to move the line around and make the point. The next equation I want to do is y equals negative 3x plus c on another slider. Okay. What I want to do is, let me change the c to a 2, like a 2. Okay, and so we can see that the lines intersect, but I'm interested in the angle between those two lines. So maybe I want to look at this angle up here, right? So the first thing I'm going to do is I'm going to use my tools to find the intersection between the two lines. And that would be, there we go, yep, they intersect, line 1, line 2. Okay, so we have A. The next thing I'm going to do is put 2 points on the lines, one on the yellow, one on the red. And what I'm going to do is I'm going to measure the angle. So I'm going to do CAB. And I see that that angle is actually 45 degrees. This is kind of cool. The question is, if I move these lines around, is that angle going to change? And so if I look at the algebra, go back to algebra, I see, yeah. The question is, so I specifically made a point that I said we're looking at the direction vectors directly affect the angle. So let's look at let's look at the sliders I created, which affect the y-intercept, but also move the line up and down to left and right. Does translating the line affect the relationship? And we can put them both on, and we see that regardless of where the lines move, the angle does not change at all between the two lines. The line is always 45 degrees apart. So the y-intercept doesn't affect it. So the angle between these two lines depends on the slope, and in vector world, the angle between two lines depends on the direction vectors. So let's now leave the video and go to the algebra. Good, we're back. So we saw in the video that we need to pay attention. We have to pay attention to the direction vectors of the line. However way they're represented in the equation, whether it's like vector, Cartesian, it's that direction vector that will help us find the angle between two lines. And other things that are coming up in the unit. So we looked at y equals 2x plus 1 and y equals negative 3x plus 2. We saw the angle between these two lines, the acute angle between these two lines was 45. So the obtuse was 135. That's neither here nor there. First thing we're going to do is we're just going to put this in, stick this in vector form. So immediately I know this is 0, 1 plus 1, 2, t. Because the slope is 1, 2 over 1, therefore the direction is 1, 2. And then this line over here is 0, 2 plus negative 1, 3 s. Now we have a couple of options. It could be 1, 3, negative 1, 3. It could be 1, negative 3. Also, I'm just going to say this, we know that the formula, the equations are not unique. But anyway, that's neither here nor there. But anyway, based on this information, these are the lines. So the direction vector of this line is 1, 2, and the directing vector of this line is negative 1, 3, and not a fraction. And so to find the angle between it, we use the cosine formula, which is, well, let me call this A, and let me call this B. And so it's the cosine formula. It's A dot B divided by the magnitude of A times the magnitude of B. And so that's basically it. And so we have here the cosine of theta is equal to 1, 2 dot with negative 1, 3 over the magnitude of 1, 2 times the magnitude of -1, 3. Well, let's see if we can figure this out in our heads. -1 plus 6 is 5 over, well, 1, 2, that's radical 5. -1, 3, that's radical 10. Remember, you have to know the distance, the magnitude. It's just like Pythagoras' theorem, actually, right? So 1 squared plus 2 squared, the square root of 1 squared plus 3 squared. And so we get 5 over radical 50, which is 5 over 5 radical 2, which is 1 over radical 2. And you should remember the cosine, you don't need a calculator for this. And the second you see 1 over radical 2, also which you know is radical 2 over 2, immediately you know that theta is 45 degrees. And so that's basically it. That's the formula. A couple of nifty little things. If the dot product, let's see, we're looking at the direction vectors. If the dot product is equal, that means the lines are perpendicular. If the magnitude is equal to the dot product, no, what is that? If the cosine of theta is equal to plus or minus 1, then the lines are parallel, or they're actually the same line. They could be concurrent. You have to figure that out. You can generally put like some order values to see if they actually arrive at the same point. You're not going to ask you that. So, for example, just quickly, let's say the direction vectors are 1, 2, 3. Is perpendicular to 3, 1k, and so find k. Well, it's the dot product. 3 plus 2 plus 3k equals 0. 3k equals 5. K negative 5. K equals negative 5/3. Now. Yeah. Other thing I wrote, I said before, that you might be, well, Mr. Adler, what if, there's negative number, but the cosine is, well, if you think about it, two lines meet, one of them is going to be acute, the other one is going to be obtuse. Obviously, if the cosine of theta is less than 0, you're looking at the obtuse angle. And if the cosine of theta is greater than 0, you have the acute angle. They'll ask you for the acute or the obtuse, but it's basically just recognizing the cosine. Now, why is this important? It's kind of cool because we can now answer questions like this. We have a quick way to answer the question: how do you find the shortest distance between a point and a line? So the question is, they're not going to say the shortest distance. The distance between a point and a line is the shortest distance. So the distance between a point and a line is the shortest distance. That's true. And if you think about it, so you have a line, any line, and you have a point. The question is, how many? Well, a student might say, hey, Mr. Adler, there's many distances. Here and here and here and here. Well, we're interested in the shortest distance, and the shortest distance is from P, and it's perpendicular. Now, it makes sense because all the green lines, like their hypotenuses, and that red line is the altitude, and the altitude is always shorter than the hypotenuse. So if I call this Q, and that's what we're going to be working on. Now, I'm going to keep this strictly in the world of vectors. So go into the world of vectors. So let's see. Find the distance between the line r equals 1, 2 plus 3, negative 1, t, and the points 5, negative 1. Okay, so let's use our diagram that we have over here. Maybe you want to pause the video and think about it on your own, or you should just watch me do the problem. So the first thing is I'm going to label my diagram because I want to do that. Let's see, this is 5, negative 1. This line here is, well, it's this line. And it has a direction vector of 3, negative 1. Now the question is, so what do I do? Well, once again, we know that PQ, which is the shortest distance, and line L are perpendicular, which means their direction vectors are the dot product of their distance of their direction vectors equals 0. So first, find the direction vector of PQ. Okay. Well, first of all, I need to know the change. The direction vector is like the slope between 2 points. So I need to find the change from P to Q. Well, I know P is 5, 1, but what's point Q? Well, we've discussed this before. Point Q is on this line. So it's some t jump. So Q is actually 1 plus 3t, 2 minus t. I don't know which t it is, but I do know if I find the t, it will get me that q. The question is now, what is PQ? Well, PQ is Q minus P, negative 4 plus 3t, 3 minus t. That is the direction vector of PQ. Once again, to find the direction, to find any vector PQ, take PQ and subtract P. Let's see. Yeah. 1 minus 5 is negative 4 plus 3t. 2 minus t minus negative 1 is 3 minus t. Next, I have to find the t. I know that PQ is perpendicular to L. I know that PQ is perpendicular to L. Therefore, I know that negative 3 plus 3t times 3 minus t dotted with 3 negative 1 equals 0. And I will be able to solve this equation, find t, get point Q, find PQ, find the distance. Let's see what we have here. Negative 12 plus 9t minus 3 plus t equals 0. 10, 15. 10t equals 15. T equals 1.5, or 3/2. Let's put that t back in there for two things. I mean, you don't need to find Q, but you can if you want to. So first of all, what is point P? Where is that point? Well, Q is, let's see, 1.5 times 3 is 4.5, 5.5, 1.5, or 3 minus 1.5 is 1.5. Now, PQ is the distance from 5.1 to negative 1 to 5.5, 1.5. But you know what? We found it already here. That's what's great about the direction vector. We don't need to do this over again. So it's negative 4 plus 4.5 and 3 minus 1.5. No, I'm sorry, Q is 0.5. This the final answer. This is 0.5 and 1.5. Now we have to find the distance, which is the square root of 1/2 squared plus 3 over 2 squared. Final answer. Let's see. We have. This is radical 10 over 4 which is radical 10 over 2. And that's good enough. That's the idea. So once again, when you're asked to find the distance between a point and a line, first find Q, which is the point where the perpendicular line meets. Second, draw the direction vector from P to Q. Third, because it's perpendicular, do the dot product with the direction vector of the perpendicular line, set it equal to 0. Solve. You can find the point, this is optional, unless asked. Find the distance, and then take the magnitude. Let's try another one in 3 space. Find the shortest distance between points P, -1, 2, 3, and a line whose parametric equations are x equals 1 plus 2t, y equals -4 plus 3t, and z equals 3 plus t. Find the shortest distance between point P, which is -1, 2, 3, and the line whose parametric equations are, let's see, x equals 1 plus 2t, y equals -4 plus 3t, and z equals 3 plus t. So you can pause the video and try it on your own. The answer is radical 26, actually. Good. Let's figure this out. So I know that, good. So I have a line, I have a point. This is my line, right? This is my point. This is my point. Let's see. It's -1, 2, 3. This is P. What's Q? Right? Because I know that I know the shortest distance, so this is the shortest distance. I need to find the direction vector of PQ. Well, what is point PQ? Well, it's in parametrics. So the question is, what is point Q? Well, Q is on this line, and we already know it's x, y, and z value. We've been given it. Once again, see if they give you the parametrics. You're in good shape. Let's see. So this is 1 plus 2t. This is -4 plus 3t, and this is 3 plus t. So we need to find the direction vector of PQ. Well, that's easy. Let's see. 1 plus 2t minus -1. That's 2 plus 2t. We have -4 plus 3t going to 2. That's, no. Yeah, minus that. That's -6 plus 3t. And 3 plus t going to 3, well, that's just t. Now, we know that this, and I don't feel like writing it over again, we know that this direction vector P2 is perpendicular to L. So what is the direction vector of L? Can we just get that from the parametrics? Yeah, you take it off the t's. 2, 3, 1. The direction vector of L is 2, 3, 1. That's what's great about this. We're going to see how important that is just by looking at the coefficients of the parameter. It gives us the direction vector. Well, what's the dot product? I guess I am going to write this over again. 2 plus 2t, -6 plus 3t, and t dotted with 2, 3, 1 equals 0. We have 4 plus 4t minus 18 plus 9t plus t equals 0. Let's see, I have 10, 4, 14t minus 14 equals 14. T equals 1. So I got time 1 So imagine this is time 0. You're walking along the shore, and there's a boat out here, and you're walking, and after 1 minute, you're at the closest distance to the boat. So after 1 minute, at t equals 1, where are you? Let's see, you're at 3, -1, 4. Okay, so at 3, -1, 4, that's the closest distance to -1, 2, 3. You can either use the distance formula, but you've already found the change. So the magnitude of P, well, so PQ is actually, what is the distance? Actually, let's see, it's 4, -3, 1, and therefore the magnitude of PQ is the square root of 16 plus 9 plus 1, which is radical 26. And yeah, that's it. So we're going to see, you're going to practice these problems, and eventually in a couple of units, in a couple of like subunits, we're going to see the relevance of this. Good.